Yes, sir. Can hear you, sir.
Thank you very much. So it's now 1 o'clock. We can start. We stopped here in the morning, where we're discussing or we're driving the estimators of the regression coefficients or regression parameters. So we have beta 1 and beta 0, or beta 1 hat and beta 0 hat as the estimators of the regression coefficients, or as the unbiased estimator. So it's very important to indicate that these estimators are unbiased. So we have to prove or to show that indeed these estimators are unbiased. So beta 1, we'll start with beta 1. So if you look at beta 1 here, it's nothing but SSXY divided by SSX. So some books uses the notation of SSXX. So SSXX is the same as SSX. And then SSY is the same as SSYY. So it's the same. Is it clear? So
Yes,
if you look at how this expression is written here, then we have the summation of xy yi minus the summation of xi multiplied by the summation of yi divided by n. And that part is nothing but SSXY. And we are saying SSXY can also be written in this way. And I indicated earlier that there are many ways. These are not the only ways of writing SSXY. You saw how I wrote them earlier in the morning. So now we want to show that this beta 1 hat, it's unbiased estimator, which means the expected value of beta 1 hat should give us beta 1. So let's go to the whiteboard and try to do that. Let's go to the whiteboard and try to do that, to show that these estimators are unbiased. So let's try to show that these estimators are unbiased. Can you see the whiteboard?
Yes.
yes, sir.
Thank you very much. So we have beta 1 head, which is equal to SSXY divided by SSXX. Guys, please mute your mic. Thank you. So we have beta 1 hat, which is equal to SSXY divided by SSXX. SSXX is the same as SSX, so don't get confused there. But what is SSYY? Is nothing but XY X bar multiplied by YI Y bar. And this part is nothing but XI minus X bar all squared. You can get this from your study guide. On the first day, we said this on the numerator can be written as minus X bar multiplied by YI. I hope you all remember this. We discussed this. We even proved it on the first day. We even proved that on the first day. Do you still remember this? That this part on the numerator can be written as this. We proved this on the first day. I hope you still remember that. If you forgot how to arrive here, so please revisit the recording and see how we moved from this to this one.
But say,
So if
but
this,
say, I see something like there is another. I think there is another way that we can explain this. I forgot.
No, we are not going to do that. We are not going to do that. Remember, we discussed that we are moving, Silo. We are moving. We cannot, like I said, we cannot want to go use your pace. So it's wrong what you are doing.
No,
it's
like say like
unacceptable.
it's general. Say like
No, Silo. We did this on the first day. I explained. We cannot come back and say now we want to re-explain what we discussed on the first day. So I'm just mentioning it, Silo, to say no, we did this on the first day. So I'm using that result. As I've said that I will always refer you to the things that we have done. Remember on the first day I said we are covering these things. We are doing these things so that in the future when I'm proving, I can always refer you to those things.
My apologies. Let's continue.
So beta 1 can be written in this way. So now we want to show that the expected value of beta 1 hat is equal to beta 1. So this is what we want to show. So we are going to have the expected value of beta 1 hat, which is nothing but the expected value of xi minus x bar yi divided by xi minus x bar squared. So the expected value of beta 1 is the same as the expected value of this. And our summation of xi minus x bar is a constant. We discussed this even in the morning. I said these xi's are constant in the model because we are given this. We are given these values. So if that is the case, then it means we have summation of xi x bar multiplied by the expected value of the variable y, and this denominator is a constant because it's a sort of function of x, and this is constant. Then from here we know that we have this part, which is the constant, multiplied by the expected value of y, and we know that the expected value of y is beta 0 plus beta 1 xi. So this is the expected value of y. We all know this. Divided by this guy, which is summation of squared. Now we have, let me erase the first part so that I can use this. Let me do this. I want to use this part. I want to use this part. So now we can expand there. If you look at that expression there, we have this part where in the numerator we have summation of xi minus x bar multiplied by the constant term, which is beta 0 plus beta 1 xi. So it means here this part can be multiplied with this, and you can see that beta 0 is a constant, so we can have it out like this, multiplied by the summation of xi minus x bar, then plus beta 1 again is a constant here. Then we have the summation of, it won't fit. Let me take it up there. Let me take it up there because it won't fit here. So what I'm doing here, is to multiply this term, with this two. So that's what I'm doing. So we are having we are having, because beta 0 there, it's a constant, we can take it out. It has nothing to do with the i's there. So we can take it out. Even on the second one, we can take this one out. Then we'll be left with multiply by, because there's this xi here, multiply by this xi. So this will be multiplied by xi. And we divide everything by squared. And this is equal to, what is this? What is this part equal to? Let me use a different color. What is this part equal to? What is this part equal to? Can someone please assist us?
It's not 0.
It's 0. We proved this on the first day. So this is equal to 0. And if this is equal to 0, it means beta 0 will be multiplied with 0, and that will give us 0. So that part is out. And what is this? And what is this?
It's the same as the denominator.
It's the same as the denominator, because of what we did here is this. So we have beta 1 summation of xi minus x bar. This is the same as xi minus x bar. So we can get rid of this x bar and have something like this. It's what we did with when we started, when we arrived to this point. It's what we did to simplify the expression that gave us this. So we can do that to this one. And if we do that, it means we're going to have something like this. So because this is xi minus x bar multiplied by xi minus x bar, this one can be written as, let me use black. This can be written as beta 1 xi minus x bar squared divided by, and these two, as you can see, they will cancel out, and we are left with beta 1. And that's what we wanted to show, that the expected value of beta 1 hat is equal to beta 1. So beta 1 is an unbiased estimator or beta 1 hat is an unbiased estimator of the regression slope. Is it clear?
Yes.
Yes.
Okay, thank you. So let's go to beta 0. Remember, we have two parameter coefficients, or we have two regression coefficients. We have beta 1 and beta 0. So we managed to show that beta 1 hat, or the expected value of beta 1 hat, is equal to beta 1. So now let's go to the second one, which is beta 0 hat, which is equal to y bar minus beta 1 hat x bar. And this is nothing but 1 over n summation of yi minus beta over n multiplied by this. So this can be written like this. We can change the y bar into 1 over n summation of yi. So the expected value of beta 0 hat is going to be equal to the expected value of y bar minus x bar, which is nothing but the expected value of 1 over n yi minus beta hat 1, or beta 1 hat over n summation of xi. So we know the values of xi's. So the xi's are constant in this case. So we're going to have 1 over n summation of expected value of yi minus, so this is constant as I've indicated, expected value of beta 1 hat. But we know that expected value of y, it's beta 0 plus beta 1 x I minus, we just proved, I'm not going to prove, but if you are the one who will be solving this in whether it's a test or what, you cannot just say expected value of beta 1 hat is equal to beta 1. You cannot do that. You will have to prove it. So we just proved, I cannot prove it again. So we just proved that the expected value of beta 1 hat is equal to beta 1. So myself, I can replace because we just proved. So please, if you are solving this, don't say the expected value we know, because we also know that, or we are also told that the expected value of beta 0 hat is equal to beta 1, but we are proving it. So if you are asked to show this, don't say we know, or don't just substitute the, please show that expected value of beta 1 hat is equal to beta 1. And now we have this, which is going to give us equal to 1 over n. So this will give us n beta 0 plus this will give us beta 1 summation of xi. And then we close the bracket. We have summation of. Now, I want to do something here. Let me use a different color. So we're going to bring in this guy to multiply all these two terms in the brackets. So if we bring in this 1 over n is going to cancel with this n and will be left with beta 0. Plus, we're going to have beta 1 multiplied by summation of xi over n. And there is plus here. And this side is going to be negative. So as you can see, this term is going to be the same as this one. And because of this negative, then these two will disappear and will be left with beta 0. Is it clear?
Yes.
Yes, sir.
No, come again.
All right, let me just write it here so that you can see. Let me use red. So what we are having there, it's 1 over plus beta 1. And this is, okay, let me even write this other one here. Oh, sorry, without a hat. Because we already, yes, it's like this. So summation of xi over n. Now we're bringing in this. So this multiplied by this will cancel the n and will be left with beta 0 plus 1 over n multiplied by this will give us beta 1 multiplied by summation of this over this minus and these two, as you can see, they are the same. So it's 0 and we are left with beta 0. So the expected value of beta 0 hat is equal to beta 0. So we can conclude that indeed beta 0 hat is an unbiased estimator of the constant or of the y-intercept. Is it clear?
Yes, sir.
Yes.
Thank you very much. Yes.
So can you go back to the formula?
This one?
Yes. Can you explain step number 2? Why do we have expected value of beta
This
hat?
one?
Yes.
All right. So Okay. The issue of xi's you are sorted. It's a constant. Christopher, are you still there?
Yes, sir.
I'm saying you are sorted with y xi is a constant. It's outside, right?
Yes, I can see it.
All right. So let me go back to this again. Let me have a whiteboard. Beta 1, it's a function. And there is y in this. So you cannot treat it as a constant because this is given by x bar yi. So squared. So this is not a constant because it has the response variable. So when we calculate, when we find the expected value of beta 1 hat, then we treat these other things as constants. We treat these other things as constants like this. But we have our response variable yi. So we find the expected value of that. So if you look at that, we are having, which is equal to minus beta 1. Let me put the head here. X bar. So this is a constant. This is a function of the response variable. Even here, there is the response variable, there's y. That's why this is not treated as a constant. That's why when we find the expected value of this, we have to find the expected value of y bar. And because x bar is a constant, we take it out and we find the expected value of beta 1 hat. Because in beta 1 hat, there's y as well. Christopher, you answered?
Yes, sir.
Thank you. Is there anyone who needs clarity? Now.
So when we want
Yes.
to check if B1 or either B0 are unbiasedness, we find the estimator of each.
You find the expected value. You find the mean of each. Yes, you find the expected. They are estimators. So you find the expected value of them, which is the mean. So now we have beta 0 hat. And we know the mean of this, it's equal to 1. And this is a part of a linear function, which is normally distributed. And because of that, this one as well also follows a normal distribution with a mean, because we know the mean. We just calculated the mean and we found that the mean is equal to beta 0. The same applies to this. It's in the linear function which is normally distributed. Therefore, this is also normally distributed with the mean beta 1. And what are the variances? So now we're going to derive the variances of these estimators. Now we are going to derive the variances of this. We know the mean and the variance of the errors. We know the mean and the variance of the response variable. Now we have these estimators. We want to know the mean and the variances of this because we know the distribution is normal. But normal distribution goes with the mean and the variance. So now we are going to look at the variances of this. We're going to look at the variances of this. And again, we're going to start with beta 1. beta 1 hat, it's equal to xi minus x bar yi divided by xi, and the variance of this, it's equal to the var of summation of xi x bar yi divided by you know what is a constant here. You know what is a constant. So a variance of a constant multiplied by a random variable is the constant squared multiplied by the variance of the variable. We discussed this on the first day. So I'm just referring you, if you forgot, that go to what we covered on the first day. So we're going to have this as a constant squared. We're going to have this as a constant squared. Squared multiplied by the variance of y. Come down here. Now, I will write it here. Let me use a different color. As a over b all squared is the same as a squared divided by b squared, which means we can square this and that. We can apply that. We can separate this. And when we do that, we are going to have xi minus x bar
Sir,
squared
on the numerator, sir,
divided by,
there is a mistake on the numerator, sir.
what's the mistake?
The variance enters within the summation.
Oh, I get what you're talking about. Let me do this. Let me erase this. So we have the summation here. Sorry, let me use the pen. We have the summation here from I to n, and we have this. All right, it's fine. Let me do it like this. Let me do it like this. Erase everything and rewrite this so that you can follow. So we are here. This is equal to, because we have this as the constant, squared the variance of yi, and we have this again as the constant squared. So it's what I did there. So we have this again.
Sir, there's a question on the chat board, sir.
I said if there's a question, please raise your hand, then I will recognize you. Because I cannot see what is on the, when I'm working on the whiteboard, I cannot see the comment section. So here we have this, which is equal to, now we know the variance of yi. The variance of yi is sigma squared. And now sigma squared is constant. So we can take it out. The variance of yi is constant. We take it
Sir.
out, we have this. Yes?
Aren't we squaring both the numerator and the denominator?
I have squared here. Sorry. If you look, this one is summation of xi x bar squared or all squared. What we're having there, let me erase this. What we're having is the variance of beta 1. Sorry, it's beta 1 hat, which is equal to xi minus x bar squared multiplied by the variance of yi. I cannot see what you are typing there. And here we have, now let me use this one so that they can be different. Or the best way not to confuse you, let me do this. Let me do this. Let me erase this and use. We know that that part in the denominator, it's equal to SSXX. So I will write using SSXX squared. So we're squaring SSXX. I believe now it's clear. Then we have this. The variance of yi, it's sigma. So we're going to have sigma squared multiplied by squared over SSXX squared. And this part, as you can see, it's SSXX. So we have sigma squared multiplied by SSXX divided by SSXX squared. So this will cancel 1 here and will be left with sigma squared divided by SSXX. Is it clear? I cannot see what you are typing. I assume it's clear. So from here, we know that beta 1 hat follows a normal distribution with a mean beta 1 and the variance sigma squared over SSXX. You are recognized.
Sir, I think you're moving too fast.
Which part you did not understand?
On the last part, you moved when I was still trying to I was still trying to analyze what you wrote and even write it down.
But I
But
asked,
then you
is
moved.
there anyone who needs clarity? And you said nothing, and then we are moving.
I wanted to
asked,
say
I
something.
cannot, but you didn't say anything. Remember, when
No,
I
like
ask, you have to. When I ask,
have
you
to
have to talk. The thing is, on this whiteboard, I cannot, like, I only have one page, so I'm writing and erasing. That's why before I erase, I will ask if you need clarity on something.
No, all right.
Yeah, so
But
please do me that favor.
Don't move like so fast. Because some of us, our
I don't.
networks are slow.
All right, I will do that. But every time when I write something, I explain so that you can move with me to avoid this
Oh,
kind
no,
of
all
things.
right.
But I get what you are saying. I will also work on that as well.
All right. Thank you, sir.
Thank you. So now we have this following a normal distribution with a mean and a variance. So we can standardize. We can have this random variable. We subtract its mean and divide by its standard deviation. So its standard deviation will be the square root of that. And this will be equal to this. And this follows, a standard normal random variable follows a normal distribution with a mean of 0 and a variance of 1. So we can standardize beta 1 hat. And with this now we can construct a confidence interval. We can also do hypothesis testing. Our challenge now is, if you look at this is a population value and we are dealing with a sample, which means we have to estimate sigma there. But before going to estimating sigma, let's look at the variance of beta 0. Let's look at the variance of beta 0. So before estimating sigma, let's look at the variance of beta 0. You are recognized?
Sir, what is the distribution of Z there at the bottom?
It's normal.
What is the mean and what's the mean? Is it
The mean
0
is
or 1?
0, is 0, and the variance is 1.
Okay. All right.
Thank you. Yes? There is another end. Okay, thank you. Let's go to beta 0. So we have beta 0 hat, which is equal to y bar minus beta 1 hat x bar. And we want the variance of this. And we have the variance of y bar plus x bar squared, because it's a constant. A variance of a constant multiplied by a variable is a constant squared multiplied by the variance of the variable. So we'll have x bar squared multiplied by the variance of beta 1 hat. Now, the variance of y bar, it's nothing but 1 over n, the variance of yi. And this is going to give us 1 over n. Sorry, this is n squared. This is n squared. So we'll have n squared multiplied by the sum of, or let me just write it. This is sigma squared. And this will give us 1 over n squared. The summation here will give us n sigma squared. And this will cancel and we'll be left with sigma squared over n. So we can replace here by sigma squared over n plus x bar squared. This one we just proved, we know it's sigma squared over ss x. And we can simplify this to, we have n multiplied by lsxx like this. Then this will give us ss, let me create a space here. So up to here, are you all sorted? Because I want to create a space here and I don't want to leave anyone behind. Up to this point,
No,
are you all sorted?
I'm not sorted from beta 1.
Beta, this part.
From beta 1, starting from the variance of beta 1.
But we finished that one and I asked and you kept quiet.
No, I had network problems.
Oh, it's fine because of I cannot redo that one now. When we finish, then I will do it.
Okay, no
So
problem.
what you can note now is that the variance of beta 1 hat, it's equal to sigma squared. I will prove this. You can just note that because we have a lot of things to cover, so I cannot go back to that, but I will do it when we are done with these things.
Okay, no problem.
Yes, thank you. So now we have this. I want to simplify.
Sir,
Yes, yes.
can you please clarify me on, I think is line number 2. I think I lost some part there where you said the variance of y bar plus. Like, how did that sign change there? I think I lost that information.
The variance of a constant multiplied by, so we are treating this as, let me write, if I can write here. We are treating this as a constant. So the variance of, and we have beta 1 at. So the variance of this will have the constant squared multiplied by the variance of beta 1. And this one squared will give us x bar squared.
Oh, thank you, sir. Now I get it.
You're welcome. So now we are here. This is the variance of beta 0. And I wanted to simplify it as well, because we can simplify it. We can simplify this to have the first thing we can do. Let me take sigma squared as a common factor here. Oh, sorry. Let me take sigma squared as a common factor. I will have 1 over n plus x bar squared over ss x x. So I can simplify to this, and you can simplify it further, and the result will be, I'm not going to simplify it further, but you can do that. And if you do that, you will end up with sigma squared multiplied by the summation of xi squared divided by nss xx. So if you simplify this, I will just give you the hints. Let me use a different color here. This is equal to this. So if you simplify this further, it will take you to this. Let me write the first step here, and you will finish it, because it's not important. When you have this, all these values, then you can get the variance. So there's no need to use this one. But again, as I've said, you don't know how the data set will be presented to you. So the best way is to know how to different ways of going to town. So you should know that from here you can also go to R81, and it will also take you to town. So from here we have sigma squared, and we have n s xx, and this to here will have ssx multiplied by 1. We have ssxx. Then these two there will have n multiplied by x bar squared will have n x bar squared. So it's the matter of changing this, because we know that this is nothing but summation of xi minus nx bar squared. So this is going to, sorry, there's a squared here. This part is going to cancel with this, as you can see, and we'll be left with sigma squared summation of xi I squared over nss xx. So that's how to simplify that. So you can simplify that variance of beta 0. Can I erase this, or there's someone still analyzing this?
Still analyzing.
You are still analyzing. Yes. You are recognized. So let's go back to the notes. Let's go back to the notes. So we were here showing that the estimators beta 0 head and beta 1 head are unbiased. So we were there showing that beta 0 head and beta 1 head are unbiased. Mahajuan, can you please mute your mic? Thank you. So we were trying to show, or we managed to show that those estimators are unbiased and also derived their variances. So now you know what is the variance of beta 1 and also what is the variance of beta 0. So for now, I'm going to skip the maximum likelihood and go to the issue of the variance. Remember, I said something concerning the variance of beta 1 and beta 0, that we have sigma there. And we have to estimate that sigma, because of sigma is a population value, and we are dealing with a sample. So we have to estimate that population with a sample value. We have to estimate the population parameter with a sample value. So let me go back to the whiteboard and explain this, because we know that sigma squared is estimated by S. We all know that, but this S is different from the one that you are used to. So I want to explain that difference, why this one is not the same as that one. In fact, it's the same, but the mean there, instead of having expected value of y, or instead of having x bar, we have y hat. We have y hat. Let me do it here. I will start with the one that you are familiar with, and having using y as our random variable. So we have this and minus 1. So what's happening here is that we are from the population 1. Okay, so let me write s squared is this, and sigma squared, it's equal to minus the population mean. Sorry, this is squared divided by n. So if you look at the two, what happened is we're replacing the population mean by the sample mean, because we're dealing with a sample. And we are losing 1 degrees of freedom because of we estimated the mean. We estimated one parameter. So we lose 1 degrees of freedom because of that reason. So we are trying to adjust this. So we lost 1 degrees of freedom. We are losing 1 degrees of freedom because we estimated this population parameter by the sample there. So if we take this to what we are dealing with now, if you take this to what we are dealing with, our mu is the expected value of y squared. If you take it to this level, and we know that our expected value of y, let me write here, we know that our expected value of y is nothing but beta 0 plus beta 1 xi. And this is estimated by yi hat beta 0 hat plus beta 1 hat xi. So this is estimated by this, which means if we want to find the estimate, the point estimator of sigma squared in simple linear regression, we are going to have the mean replaced by the point estimate, and that is that which is yi hat divide by, we divided by n minus 1 because we estimated one parameter. We lost 1 degrees of freedom. Here we have 2 parameters. So we are estimating 2 parameters. We are losing 2 degrees of freedom. So this becomes the point estimator of this. Now one can now estimate the variance of beta 1 hat using S squared over SS x. So one can estimate the variance of that using that. If you have a sample data, you can use this formula too. And again, if you recall, I said beta 1 follows a normal distribution with beta 1 and sigma squared over SS x. And now from here, we said we can standardize beta 1. And when we standardize beta 1, we have Z minus beta 1 over sigma SS XX. And this follows a standard normal. But because this is not known, we are estimating this using S. Now we're going to have, if you recall what we discussed, or I don't know, those who are coming from ECP, I'm not sure if you discussed this or which approach did you use, but those who are coming from mainstream, we discussed that if the population standard deviation is not known, we go for T. You know that. So because this is not known and we are estimating, now this changes to be divided by S, the square root of SS XX. I cannot see what you are typing. And this
Nothing
follows a
important,
student
sir.
distribution. Okay, thank you. So this follows a student T distribution with n minus 2 degrees of freedom. So we have estimated sigma by S because sigma is not known. So we are estimating using S. And that's how the distribution, we are ending up with T distribution. It's because sigma was not known and was estimated by S. But S, what is this S? Let's go back. Or let me just erase everything here. What is this S? If you look at this S, we are saying S is equal to yi minus yi hat squared divided by n minus 2. What is the summation of, or what is this term here? Let me change the color so that you can see. This term in red is the errors. It means we're having the sum of the errors squared divided by the degrees of freedom. And the sum of the errors squared, we said earlier, that is SSE. The sum of squared errors divided by the degrees of freedom. And you know that when we have the sum of squares divided by the degrees of freedom, or the error sum of squares divided by the degrees of freedom, we get the mean square error. So this becomes MSE. So this S, or S squared, by the way, it's nothing but MSE. This S squared is nothing but MSE. So this is nothing but MSE. Is it clear?
Yes, it's
Is it
clear.
clear? Thank you very much. And then another thing that we can get from this, is that we have our SSE, which is equal to yi minus yi hat squared. And we know that our yi hat is nothing but beta 0 hat plus, but because of this negative, then this one will also becomes negative xi squared. We know that. And another thing that we know, another thing that we know is that this guy, it's equal to y bar minus beta 1 hat x bar, then minus the last term there, squared. And from here, we have yi minus y bar plus, so this becomes plus beta 1 x bar minus beta 1 at xi all squared, like that. And this becomes, this we can arrange to be one term. This is one term. Now I want to start with this part of negative, so I will take negative beta 1 hat, then I have xi plus, so because I'm taking negative as a common factor, that plus will becomes negative. So this part will be negative. So we'll have negative x bar all squared. Then from here, it's more like we are having, I'm going to treat this as two terms. I'm going to treat this as something like a minus b all squared. And this is nothing but a squared minus 2ab plus b squared. So I'm going to treat this like that. We still have the summation outside. So we're going to have yi minus y bar squared minus 2 beta 1 hat xi minus x bar multiplied by yi minus y bar plus beta 1 hat squared multiplied by xi minus x bar squared. Are you all following?
Yes, sir.
Thank you. So because of space, I'm going to remove this first part so that I can put the next step. So I'm going to replace this. So I'm going to replace this. Remember, I cannot see what you are typing there.
They're saying they need a break, sir.
What time is it? No, I think the break time has passed. We are left with about 20 minutes. So if I don't want to stop at 22. I want to stop at past. So if we take a break now, it means we're going to stop at 22, 3. And I want to stop at past. I think the issue of break will be, as soon as we have class reps, then it will be the responsibility of class reps to stop me after each and every 45 minutes. So I believe from next week we'll be having class reps, so it will be their responsibilities to remind me. So let's finish this. We are almost done. Let's finish this. We are almost done. So from here, I want to bring in the summation. As you can see that the summation is outside. So I want to bring in the summation. I want to bring in the summation. So we're multiplying everything by the summation. The first term will become, because there's an I there, the first term will become this. Then minus, this is a constant. It's calculated. Then we have xi minus x bar multiplied by y I minus y bar plus, this is a constant again, squared summation of xi minus x bar squared. And you know that this is nothing but SSY or SSYY, depending on how you want to write it. So it can be SSY or SSYY minus 2 beta 1 hat. This becomes, or it's equal to SSXY, and this is beta 1 squared, and this is SSXX. And we know from the previous formula that we know that beta 1 hat is equal to SSXY over SSXX, which means SSXX is nothing but SSY divided by beta 1 hat. So if you make this subject of the formula here, you will have this. So I'm taking this and substitute it here. So I'm going to have SSYY minus 2 beta 1 hat SSXY. So I'm replacing this by this. As you can see, there's a beta in the denominator. So this beta will cancel 1 because there are 2 here. So we'll be left with 1 beta there. Hat SSXY. So now we have 2 of this term and 1. And because of the negative, we're going to lose 1. Is it clear? And because of the negative there, we're going to lose 1. And when we lose 1, we end with this part is still there. So these 2 will eliminate and we'll be left with beta 1 hat SSXY. Are you all with us?
Yes.
Thank you. Now, I want to explain something here. I believe you all did this ANOVA thing. So from ANOVA, I want to erase everything. Can I do that? I want
Yes,
to
sir.
erase everything.
Yes, sir.
Thank you. Thank you. So from ANOVA, we know that SS total, it's equal to SS reg plus SS errors. So if you look at what we're having, here we're having SS errors in our, or what we're driving. Then here we have SSYY minus beta 1 at SSXY. So if you rearrange this, you take the errors this side, or you take this negative part to the left or to the right, we'll have SSE. This negative becomes a positive, SSXY equal to SSYY. So if you relate this to this, SSYY is subject of the formula, then it's our SS total. Now we have the SSE, which is this, and which means this part is our SS reg. So now we have the SS total, SS reg, and SS errors. Is it clear? Then we can set up an ANOVA table. So now you can test
Mr.
using
Chabalala,
Mr. Malaga.
I suggest you finish the section that you are dealing with now, and then we'll select the class reps tomorrow during the tutorials.
Okay, no problem. Thank you.
Yeah, because we expect all of them to be there, isn't it?
Yes.
So let's deal with this issue of class reps during the tutorials tomorrow.
Okay, no problem. Thank you.
Okay, thank you.
Please mute your mic, Makofane. So we are here. We are dealing with or we're estimating. I was explaining how or why we are having that S which is equal to SSE divided by n minus 2 degrees of freedom. And that SSE divided by n minus 2 degrees of freedom becomes MSE because it's the errors divided by their degrees of freedom. So that gives us the mean square error. That gives us the mean square error. So if you look at this part, we just proved the numerator here that SSE is equal to this part in the numerator. So if you divide what we just proved by the degrees of freedom, you will get the MSE. So this is nothing. It's what we just proved that SSE is equal to SSYY minus beta 1 hat multiplied by SSXX. So we are from there. We are not going to spend our time there. Well, we have covered that part. And this is to emphasize that sigma squared is estimated by S squared, which is equal to MSE, which is equal to SSE divided by n minus 2. Now we have exercise and we have covered this part. We just proved this. So I'm not going to again spend time on that one. I'm not again going to spend time on that one. And another thing here, if you look at this, it's SS total because this is SS YY. Please correct this on your study guide. The Y bar should not have an subscript either. It should be Y bar, so it's constant. So please correct this in your study guide. Remove that subscript there on Y bar. Remove the subscript on Y bar. Please, 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 please do that. Remove the subscript on Y bar. Please remove the subscript on Y bar. Now, this is the SS total. And as you can see, this part is the errors because we have the actual value minus the predicted. So these are the errors, which means this is nothing but SS reg. It's nothing but SS reg. And if you look at exercise 2, we want to prove that indeed SS reg is equal to this part, which is beta 1 hat multiplied by SS xy. So we are going to do that now. We are going to do that now. So we're going to show that this part is indeed equal to beta 1 hat SS xy. So let's go to the whiteboard. Let's go to the whiteboard. What I need, you have a lot of proofs here. They are still coming. So we are not done with proving. They are still coming. So there are a lot of proofs. That's why I indicated on the first day that you have to at least grab those results, because you will need them to prove a lot of things. We are still going to prove. But for today, I believe this is the last one. I'm going to give you the other one as an exercise. But the one that I'm going to do now is the last one. The one that I'm going to do now is the last one. So what we want to show here is that the summation of yi hat minus y bar is equal to, this is squared, of course. It's equal to,
Say your screen.
thank you. I don't know what's happening because I've projected. Let me start from scratch. And then we are here. Can you see now?
Yes.
Yes. This is what we want to show. So we are here, yi hat minus y bar squared. This is a simple proof. We know that this part is equal to beta 0 hat plus beta 1 hat xi. Then we have minus y bar squared. As you can see here, we don't want beta 0, we want beta 1, which means we have to change beta 0 there. That's how to get these proofs. So they will guide you. If you pay attention, they will guide you. So we have to change this. And this we know that is equal to y bar minus beta 1 hat x bar plus this part minus y bar squared. So this y bar and this one, you can see they will cancel out. It's clear there. Those two will cancel out. And you have, now I'm starting with this. I have beta 1 hat xi. Then I'm taking beta 1 hat as a common factor. This side I will be left with this. And these are squared. So what we are having there, let me use a different color. What we are having there is this. We have a multiplied by b all squared, and this is a squared multiplied by b squared. So I'm going to do that here to n. This will be beta 1 hat squared, and this one will be squared as well. You are recognized. Oh,
Can
sorry.
you explain step 3?
I don't know what happened. I pressed delete by mistake and everything is gone. Step 3, what was there? Can someone please remind me? I'm sorry about that. I don't know what's going on. I pressed delete by mistake. Yes.
Sir.
Yes.
I think they can do there.
Yeah.
We're somewhere here. Let me go back. We're somewhere. We just replace y beta 0 by this.
Just press and do
beta.
there.
Thank you very much. Let's see what happens. It's not working. Oh, it's here. Thank you very much. So we are here. So this one, I said it's squared. You were saying I should explain which step, this one. Or let me circle it.
Yes.
You are saying I should explain this.
Yes.
So from here, we have beta 0. As you can see, what we want to prove does not contain beta 0. So we don't want this beta 0. We have to get rid of beta 0. And how do we do that? we know that beta 0 is equal to y bar minus, you are recognized. Guys, let me finish this. Someone has asked a question. I thought maybe you cannot see what I have projected, but if it's a question, then you will have to wait for me to finish explaining this. Please mute your mic and allow me to explain this. Given, please mute your mic and allow me to finish. Thank you. So we are here, and I was saying, as you can see, what we want on the right has nothing to do with beta 0. So we have to get rid of this beta 0. And how do we do that? We know that beta 0 is equal to y bar minus beta 1 hat x bar. So we are replacing this by this. And we leave the other terms there. We leave these other terms here as they are. Then from there, there's positive y bar and negative y bar. So these two, they can cancel out. And then when they cancel out, we are left with, let me write it here if it will fit. Okay, let me not use equal to because I'm not going to write the summation. We are left with minus beta 1 hat xi plus beta 1 hat x bar. And I can write this as beta 1 hat starting from this side. And then, sorry, the x bar is here and the xi is this side. So I can start with xi minus x bar. So this is what we have from here. We are left with that, and that gives us this. And from here, I used this. AB all squared is equal to a squared multiplied by b squared. And now we have this. Is it clear? Is it clear? So now we can simplify this because beta 1 hat squared is a constant. So if we take that one out, we are going to have beta 1 hat squared summation of xi minus x bar squared. And this is equal to what? We know that this is equal to beta 1 hat squared ss x. And we know our SSXX, it's equal to SSXY divided by beta 1 hat. So we can take this and replace here. So this beta will cancel 1 here, and we'll be left with 1 beta hat multiplied by SSXY. And that completes the proof. Are we together? Guys, are you following?
Rosa.
Yeah.
Yes, sir.
Okay. So that is the case. That's how to prove that one. So let me go back to the notes. Then it's fine because you're complaining. We are also going to prove these 5 properties here. So we are not going to do that today. Of course, we'll do it on Thursday next week. So for today, as I've indicated that I'm going to give you a homework. I'm going to give you a homework. I want you to go and do this. I want you to move from here, from the left. So let me just write it down on the whiteboard so that you can follow. I want you to go and try this. I want you to go and try this. I want you to go and try this. Summation of yi minus y bar squared. We are saying it's equal to summation of yi minus yi hat squared plus yi hat minus y bar. So I want you to go and derive this. So from here, you must end up with this. So I want you to go and expand that. Another thing that I'm aware of is that, or the hints that I can give you, when you move from here, you introduce 0 in the form of, here you're going to introduce 0 in the form of yi hat minus yi hat. So this is 0. So you're going to introduce 0. Let me do this. Now I made a mistake. Sorry. I want rubber thing. So this is plus, because this is 0. Then the minus y bar, it's here. So you have introduced 0. Now you can rearrange. As you can see, yi must go with negative yi hat, which means this negative yi hat is going to join this, and this one will be joined by this, and then they will give you this part. And this is sort of, we're going to have a, is it a plus? Yeah, we're going to have a plus b all squared, and this will be equal to a squared plus 2ab plus b squared. So our ab is these terms. Our ab is going to be yi minus, and this will be our ab. The difficult part is here. This term is equal to 0. So I want you to prove that this term is equal to 0, because the other terms are straightforward. The middle part, because a squared is this, which is this part, and b squared is this part, but 2ab must be equal to 0. So I want you to get that. I want you to get that. Another hint that I can give you from here is, I can also open your eyes here. Is this? Let me do it here. Now this term, if you look at the first one, if you look at this is E. So it's more like we are having summation of E multiplied by yi hat minus y bar. So I want you to prove that this is equal to 0. So it's going to be part of the tutorial questions. I'm going to give you, or to send you, the tutorial questions today on Blackboard, and please include this. Prove that this is equal to 0. Because if we can
Sir,
prove this, yes.
I want to ask something based on the one that you give us, the one that of summation yi minus y bar squared. Do you see the last thing there, the summation of yi hat minus y bar squared? I want to ask you, do we expand it now? Just the hint.
You expand which one? I think
the summation.
let's start. Are we here? Are you talking about this?
Yeah, exactly.
Yes, I gave you a hint that this you are expanding it to be equal to this. You are introducing 0 in the form of yi hat minus y bar hat. So you are introducing 0 like this. And when you introduce 0, now you start arranging the terms because this is guiding you. You want yi to go with minus yi hat. So you make this one term. You want yi to go with this. So you're going to make this to be your one term. This is your age. Then it means that the remaining part, which is yi hat minus y bar, is going to be b. So now you're having a plus b all squared. And when you have a plus b all squared, is going to give you this. So your a squared is what you want, your b squared is what you want, because a squared is this and b squared is this, which means this term has to disappear, the middle term. So I want you to make this term disappear. Is it clear?
Oh.
Yes. I want you to make the middle part disappear there because we don't want the middle part, but it's there. So that part, it's equal to 0. I want you to prove it that this part is equal to 0.
Sir.
So using all the things that we have discussed so far, please make that part to disappear. You are recognized.
I wanted to ask based on the one that you said we must introduce. Let's take for future proofs, like proofs that we are not aware. Let's take it comes on exam.
Yes.
So can you please clarify me? How will I know here I'm supposed to introduce something like this? Yeah, that part of.
No.
Because it might happen that I get stuck on that line without knowing what I must introduce something.
Then you'll have to find a way out. This is some of the things that I cannot teach. Like I can't teach. Like it's like how I was doing the proofs. I was telling you that I will use the example with the previous one. I said on the previous one that because I can see what I want to achieve, there's no beta 0. It means I have to find a way of getting rid of this beta 0. So I cannot, like, you have to think about that. Like there's no one to coach you on that one. So it's the same thing here. You try all things, you can see that they are not working. Then now you think, how can I deal with this? Then you find a way. So that is the beauty of these things. It's about thinking. You have to think out of the box. You get something out of what you have taught in class. So that's how it's going to be. So there will be no hints to say introduce 0, because again, that is not the only way of doing it. But because that is simple to me, then I prefer that. There are other ways of doing that. There are other ways of doing that. So you might find that someone wants to prove that the SS total is equal to the error and that, but does not use the approach that I used. So even that one is possible. But in this case, I want you to follow that to show that the middle part is equal to 0. So that's what I want you to do in this case. So the reason I'm channeling you to go through that or to use that way is because I'm interested in making the middle term to disappear.
Sir, is this still chapter 1 or 2?
No, we're still on chapter 1, and we still have a lot of things to cover under chapter 1. Yes, we still have a lot. Remember, I said after driving the betas and the variances, I said we can construct an interval. So we are still going to construct confidence intervals for the regression coefficients. We're still going to test. If you go back, let me project this. Maybe you guys will follow. Let me project this. You can't be crying, guys. You are exiting. You are doing final level, so you are exiting. So this is nothing. This is nothing. You can't be expecting what you covered in first year. We are here. We examined the relationship. It looks linear. We estimated the model using the least square method. And I forgot to go back to, so you have to remind me next week. I forgot to go back to a maximum likelihood. By the way, we are done. Those who want to leave, they can leave. Let me stop recording.